You have them, I have them. They are on your phone right now. But why? What is the actual evolutionary purpose of those tiny ridges and furrows on our fingertips? For decades, the answer seemed obvious: grip. They help us hold things. They help primates climb trees. Case closed, right? Well, not exactly. Scientists have been debating this for years, and recent research has completely flipped our understanding. Some studies even suggest fingerprints might actually reduce grip on smooth surfaces. So if it is not for grip, why do we have them? Welcome to Grossdenken, everyone. Today, we are going to uncover the surprising science behind your fingerprints. Please support this channel by just subscribing. That would mean a great help. Let us start with the grip theory. It sounds logical. Ridges create friction, right? Like the tread on a tire. Well, in 2009, a team at the University of Manchester tested this and found something shocking. They discovered that human fingertips behave like rubbery materials, not hard solids. The ridges actually reduce the contact area with a smooth surface by about 1/3. Less contact area means less friction, not more. As biologist Roland Enos put it, fingerprints will actually reduce friction. This casts serious doubt on the grip hypothesis, at least for smooth surfaces. But in 2020, a major study published in PNAS offered a more sophisticated answer. Researchers found that fingerprints are not about static grip. They are about dynamic moisture regulation. Here is the key. Our fingerprints have a remarkably high density of sweat glands. About 25% of all sweat glands on our body are on our hands and feet, which make up only 5% of our skin surface. When you touch a smooth surface, the ridges release just the right amount of moisture to soften the skin's keratin layer. This makes the ridges stickier, dramatically increasing friction. But if you get too sweaty, excess moisture is wicked away through the furrows, the valleys between ridges, and evaporates quickly. The furrows act like tiny microfluidic channels. The system regulates moisture to maintain optimal hydration, the sweet spot where friction is maximized. Too dry and you slip. Too wet and you slip. Your fingerprints keep you in the Goldilocks zone. But grip and moisture regulation are not the whole story. There is another fascinating function: enhanced touch sensitivity. In 2009, researchers at the École Normale Supérieure in Paris used a biomimetic sensor, an artificial fingertip, to show that fingerprints amplify vibrations. When you scan your fingertip across a textured surface, the ridges act like a mechanical filter. They selectively amplify vibrations with wavelengths similar to the distance between ridges, about 0.5 millimeters. This amplification is crucial for detecting fine textures. It helps the Pacinian corpuscles, deep nerve endings about 2 millimeters below the skin, pick up subtle vibrations. Without fingerprints, your ability to feel fine textures would be dramatically reduced. This tactile advantage likely evolved in our primate ancestors for tasks like assessing fruit ripeness, a hypothesis supported by studies showing frugivorous primates have more touch receptors in their fingerprints. So which explanation is correct? The answer is likely all of them. Here is the current scientific consensus. Fingerprints appear to be a multifunctional adaptation for arboreal living. They provide superior grip through moisture regulation when gripping branches and objects. They enhance tactile sensitivity for foraging and tool use. And there is a third hypothesis. They may help prevent blistering by allowing the skin to deform more easily under shear stress. The leading theory is that fingerprints evolved as a package deal, a set of adaptations that gave our primate ancestors a crucial advantage in the treetops. Here is one more fascinating fact. The only other animals with fingerprints like ours are primates and koalas. They evolved them independently. Why? Because they too need to grip branches and manipulate food in their environment. Scientists still have not fully resolved the debate. The relative importance of grip, touch, and blister prevention is still being studied. But what we do know is this: your fingerprints are not just for identification. They are sophisticated sensory and mechanical tools shaped by millions of years of evolution. So why do we have fingerprints? Not for grip in the way we once thought, but to manage moisture for optimal friction, to amplify subtle vibrations for fine touch, and likely to prevent blisters. The next time you touch something, remember, your fingertips are doing far more than you think. Thanks for watching, and hit subscribe for more deep dives into the science of your body.